In sentential logic, we enriched our system of natural deduction with a system of derived rules. We can do the same with predicate logic, and in fact, today we're going to introduce two new rules. One is the rule of contradiction, and the other is the rule of quantifier negation. So let's begin with the rule of contradiction, abbreviated as CD. This is a rule that can be very puzzling when you first encounter it, but it's quite useful, and it's based on the fact that whenever you have a contradiction, then on any subsequent line in the derivation, you can write any PL sentence. Thus, any PL sentence whatsoever is derivable from a contradiction, where by contradiction we mean the occurrence of both a sentence and its denial. Again, at a first glance, this is one of the most surprising facts about classical logic. The more general idea is that when you have a sequence of sentences and at some point you reach a contradiction, that is, you encounter both a given sentence and its direct negation, it is as if the whole set of sentences explodes. It bursts open. It's a logical catastrophe. And as it often happens in times of catastrophe or disaster, anarchy sets in, a system of rules breaks down, and so people are able to do whatever they want. You are permitted to derive any sentence you want. Now, I'm not going to provide an actual proof of this, but I can help you make sense of it with a parallel fact about arguments, which is that if you have an argument with an inconsistent set of premises, then any conclusion will validly follow. So suppose you have this argument: I am here, I am not here, therefore Salt Lake City is in Bulgaria. Is this argument valid or invalid? Well, surprisingly, it is valid. If it were invalid, then you would be able to build a counterexample for it. But remember that a counterexample is a scenario with two characteristics. The first one is that in it all the premises are true at the same time, and the second is that the conclusion is false. However, the first requirement can never be met, since it's impossible for both of these arguments' premises to be true at the same time, as they directly contradict each other. This means that there is no possible counterexample to this argument, and so, by our definition, it is automatically valid. Notice that the validity of this argument depends exclusively on the inconsistency of the premises. The nature of the conclusion is indeed a matter of indifference. I could replace the conclusion with any conclusion I want. For instance, Salt Lake City is in the North Pole, or I have a flying dog, anything. Any conclusion will yield a valid argument. On the other hand, getting validity on the cheap has its additional costs, since none of these arguments is going to be sound, precisely because it is impossible for both premises to be true. There isn't complete agreement on whether this characteristic of classical logic, which is sometimes called the principle of explosion, and it is also sometimes given the name ex falso quod libet, which is a Latin name, well, there is no complete consensus on whether it is a bug or a feature. But what matters to us is that it can be very useful in certain situations, especially when you're using a contradiction-based rule, such as negation introduction and reductio, inside the context of existential exploitation. You'll see what I mean in a minute. But first, let's state the rule. It says that if on a given line you have a sentence X, and on a line below that you have the negation of X, then on a subsequent line you can write any closed PL sentence. However, it's going to be convenient for us to explicitly mark that we have arrived at a contradiction. And to do so, we can write any contradiction whatsoever, but it's best to avoid sentences that contain individual constants, like lowercase a, b, c, etc. So, for instance, you can use sentence letters and write A and not A, or B and not B, or you can use our handy symbol, the falsum, which is defined as the negation of a logical truth and is thus guaranteed to be false. Thus, whenever you arrive at a contradiction, you can mark it by writing down the falsum on the following line, and then justify it by indicating the lines of the mutually contradictory sentences. In this case, lines n and n plus m. Okay, here's an example. Suppose you want to derive this sentence, there isn't an x, fx, from this other sentence for every x, not fx. Now, as you can see, this is a valid inference, and therefore it should be doable. So we set out an argument with this sentence as the sole premise and this other sentence as the conclusion. We start then with our premise. Since our conclusion is a negated sentence and we don't have much else to work with, it looks like a good strategy for deriving it would be to use negation introduction. So we have to open a subderivation, and the assumption is the conclusion we want to reach, minus the negation. So we write there is an x that is f. We mark it as our assumption for negation introduction. Now our strategy is to look for a contradiction. Once we have our contradiction, we'll be able to tack a negation sign onto our initial assumption. So how do we proceed from here? We have two quantified sentences so far. One is universal, the other existential. Remember that when we have the choice of exploiting a universal or an existential sentence, we should start with the existential. And this is what we're going to do. Since we are exploiting the existential, we have to open a subderivation, and we have to choose a name whose occurrences are going to be isolated. The name A hasn't appeared yet, so we're going to use it. As an assumption, we're going to use a substitution instance of the existential sentence in 2, using the name A in place of the variable x. Okay, now we can get the contradiction we were looking for, because if we exploit the universal in 1, using the name that is already in circulation, then we get not fa, which is the direct negation of the sentence in 3. So what can we do at this point? Should we just close the subderivation and introduce a negation? Well, you can't do that at this point because this sentence here would have to be the conclusion of the subderivation that we started in 2. And so we would be closing the first subderivation without having previously closed the second one. But this violates the idea that each derivation must be completely embedded inside the previous one, like Russian dolls, so that the last subderivation you open must be the first that you close. In short, subderivations can never cross lines. So if we were to write the conclusion on the first derivation in this very place, we would be forced to close the first subderivation without having first closed the second one. So our subderivation lines are crossing, which is illicit. But perhaps there's another way we can get our subderivations in order. Here's another possibility. Let's explicitly signal that we have arrived at a contradiction by conjoining fa and not fa. Then we close our subderivation, and then copy the last line onto the next one by existential exploitation 3 through 5. Then we can close the subderivation, and since we have the needed contradiction, we can attach a tilde to our initial assumption, thus obtaining the conclusion we wanted. Now, this strategy avoids the problems of what we did before. It allows subderivations to be completely embedded one inside the other, and it delivers the right conclusion. Alas, this derivation doesn't work either. What is the reason? I'll let you think for a second. Okay, did you find the mistake? Yes, the problem is that by taking the sentence in 5 and copy it in 6, we make it so that the name A appears outside of the derivation in which it was introduced. So the name A is not isolated in this derivation, and in consequence, this use of existential quantifier exploitation is illicit. It is illegal. What should we do then? Well, we can use the rule we introduced a couple of minutes ago, the rule of contradiction. So I can say, given that I have a sentence in line 3 and its direct negation on line 4, then the principle of explosion allows me to write any sentence whatsoever on line 5. But remember that the rule of contradiction tells us explicitly to write a contradictory sentence. Any contradictory sentence, really. So we could write A and not A, for instance. But we will use the falsum symbol. Okay, now we justify this by CD, which is the abbreviation of the contradiction rule, from lines 3 and 4. So we can discharge our assumption. Close the subderivation, and by existential exploitation, we can export the last line to the next derivation. Then we write the falsum again, and we justify doing so by citing line 2, which contains the existential we are exploiting, and lines 3 through 5, which encompasses the relevant subderivation. Notice that this use of existential exploitation is legitimate, since there is only one name in our subderivation, namely A, and that name occurrence is isolated. This was possible because in exporting the falsum symbol, we are not smuggling any names out of the subderivation, since the falsum doesn't contain any name. That's how we can avoid the pitfall of our previous solution. Okay, we started our subderivation with an assumption on line 2 and ended up with a contradiction on line 6. So we can close it, and on line 7, we can add a negation sign to our initial assumption. And so at last, we get the conclusion we wanted. It's not the case that there is an X such that fx, and this is by negation introduction, lines 2 through 6. So this is a case in which the derived rule of contradiction was essential. Thank you. Goodbye.